Hello students, Jai Swaminarayan. I am Professor Urvish Mewada, HOD Electrical Department, Sri Swaminarayan Institute of Technology, Bhat, Gandhinagar. I am the subject matter of Interconnected Power System, which is in the 7th semester Electrical Engineering GTU, and subject code for the subject is 2170901. Students, today we are going to discuss the chapter number 3. In last lecture we have finished the chapter number 2, and the topic was the topic that we discussed in the chapter number 2. The last topic was the example based on the Y bus and Z bus analysis. So we are starting with the new chapter today, chapter number 3, load flow studies. So in this chapter, the lecture number 1, this is the lecture number 1, and the topic number 1 is introduction and necessity of load flow studies. So before we start this load flow studies, first of all we need to understand that what do you mean by load flow. See, if we talk about a power system, then this power system consists of different zones, say generating, then transmitting, and the distributing. So generation, transmission, and distribution, in between we have lots of devices, they are connected in the system, and due to that devices offer their own characteristic and their own internal resistance and the own reactances. So due to this devices and the elements which are connected in the power system, due to that elements we need to check, or we need to send the optimum amount of power at the sending end, so that we can means that power is say including the losses, and means by considering the losses we need to send the optimum amount of power, so that we can receive at the receiving end a proper, means a rated power at the receiving station. So this is nothing but the load flow, means for particular load we are driving or we are giving the input power, and that power is transmitting through the transmission line, and we need to check or we need to calculate all the parameters related to the transmission line to calculate the losses, and to calculate the means effect of the active power, reactive power, and the apparent power, means the quantity of the active power, reactive power, and apparent power that we are transmitting from generating station to the receiving station. So this is nothing but the load flow studies. So let us start with the load flow studies with the first topic, that is introduction of the load flow studies. So basically load flow, or we can say power flow studies, that comprises of determination of current, voltage, active power, and reactive power at various point in power system operating under normal and steady state condition. See, as I discussed that when we transfer the power from sending end to receiving end, so power is consist of say current, voltage, and we have three different powers, say active power, reactive power, and the combination of these two powers are the apparent power. So we need to check all the parameters of this quantities at a different level of the transmission system, and this system is say called say normal or steady state condition, means there is no load is not varying at that time, means we are checking that this system is we are checking all the parameters only when the system is at steady state condition. So this is the load flow studies, and it is very important for the planning. See why the load flow studies is study is important. So we can do the proper planning of transferring power from sending end to receiving end, then we can control that power as per our requirement, and we can perform the operations that we the operation that we perform for our desired output of existing system as well as the future expansion. So this we consider all these parameters, and one more important parameter is the future expansion, means if we design a system having say load x load, and if the population of that particular area increased day by day, and means the expansion of the say of that area, due to the expansion of that area, means due to the population of that area. If population increases, then we need to means expand our system also, so that we can fulfill the consumers demand. So load flow studies comprises of all three parameters. So we can plan the transmission, we can control the transmit power, we can do optimum operations that we required, and we can calculate the load flow studies by considering the future expansions also. It is help in say ascertaining the effect of new loads. Means as we know that loads are means increasing day by day. So the new loads which are connecting with the system, and the new lines which we are connecting with the means power system. Means as load increases, we need to increase the lines that can transfer the new loads to towards the consumer, and the new generating stations and the new interconnections before they are installed. So when we calculate this load flow studies, at that time we keep in mind this parameter planning, control and operation. And then after this is the this includes the future expansion. Means according to this future expansion, we calculate this load flow studies, and we can give optimum power to the consumers. We can give the pure power to the consumer, and we can fulfill the consumer demand, and we can maintain the generation to the demand ratio with the help of proper load flow studies. Now this is the need of load flow studies. So first is we can design in the designing of power system, we can use the load flow studies. Now we can as we discussed in this introduction, but we are just referring again, and we can use it for the planning of the power system. The future expansion is also a main factor while we perform the load flow studies. And it provides the guidelines of optimum operation of the power that I already discussed. That for the optimum operation, means without wear and tear and without failure of the power, we can give the pure power to the consumer, or we can drive the load. Means appropriate we can give the appropriate power to the consumer, and we can drive the load. So that is called the optimum operation of the power system. Then it provides the guidelines for various power system studies also. So whenever we perform the load flow studies, it gives the information about the power transformation, as well as the it can be useful for the future expansions and expansion and planning and operation of the power system. So this is the introduction of load flow studies and the necessity of the load flow studies. Now let us discuss the topic number 2 of this chapter, is static load flow equations. So this is the most IMP question for of this chapter. So please pay attention over here. Let us discuss the static load flow equations. So first of all, the static load flow equations means the load is say steady, it is not varying, means it is fixed, or means there is no fluctuation in the load. So generally load flow studies provide a systematic mathematical approach to calculate the magnitude and phase angle of the voltage. This is the most important factor of load flow study, the magnitude and the phase angle of the voltage. So from that we can calculate the active power, reactive power, apparent power, and all the means the losses related to the power system, and at the buses, and also the active power and reactive power for the given terminal or bus conditions. So it describes the all the powers, means active power, reactive power, and as well as the phase angle, and the additional thing is that it describes the bus conditions. So so from that all these powers we can define the bus condition also with the help of static load flow equations. So the things that we can calculate with the help of static load flow equation is magnitude of the voltage, say mod Vi, and phase angle of the voltage delta I. This is the phase angle between the phases, means this angle describes the transmission of the power, means as we already discussed that P is equal to EV by X sine delta. So if delta is say 90, at that time the power will be maximum. So this phase angle describes the condition of the maximum power transfer. Then active power Pi, reactive power, that is in volt ampere, or it is indicated as a Qi. So the load flow problem can be solved with the help of load flow equations. So we are deriving this static load flow equations. Now the bus admittance matrix that we already derived, y I is equal to Vy. The equation is I is equal to Vy because y is the reciprocal of the impedance. So Z is equal to V upon I. So y is equal to I by V. So from this we can form the matrix for the I is equal to V into Y. So the admittance matrix Y bus is say I into Vi. So we have, suppose we are considering the 3 bus system. So we are having the 3 by 3 matrix. So that's why for all three buses the currents are I1, I2 and I3, and the voltages are V1, V2 and V3. And for this lines the admittances are say Y1, means Y1, Y2 and Y3. So this all are these all buses are interconnected. So we can form the links, means the admittance between links and the bus itself. So let us discuss that. The equation for the bus 1 can be written as, say, I is equal to Vy. So here we have the I1 is equal to V1 Y1 1, then V2 Y12, and then V3 Y13. So from that matrix multiplication we can define the equation for the I1. Then similarly we can write the equation for the I2 also. So Y21, Y22 and Y23 means this is the say I2. That's why the first term remains 2. So Y21, then 22, then 23, and the voltages are same, then V1, V2 and V3 of all the buses. Then similarly we can write the equation for the bus number 3. So it is Y31 V1, then Y32 V2 and Y33 Y3 V3. So in general we can write this equation in like it is the summation of all the say admittances. So it is k is equal to 1 and up to n. So we can have the nth number of buses. So we can derive this equation for the nth number of buses. So this II will be the sigma k is equal to 1 to n yik Vk, where I is equal to 1 to n. So the complex power equation, if we want to write by this ith bus of the power system, then Si is equal to Pi plus jQi. So we can write the above equation with the help of the conjugate of the current. So as we already discussed this equation in the previous lectures. So Vi is equal is multiplied with the Ii conjugate. So I is equal to 1 to n. So we are finding this I means current for the nth number of bus, where Vi is the bus voltage at the ith bus with respect to the ground. Means this is the voltage with respect to the ith number of buses, and it is respect to the ground. Means all the generators are say having say grounded, means one terminal of all the generators are grounded. So it is including the ground potential respect to the ground, and I conjugate is the source current injected into the bus. So this is the current that we are injecting into the bus, and after that we can use that current for the load. So the load flow problem is entertained more conveniently either the use of II rather than I I conjugate. So from that we can again rewrite the equation, and we are taking the complex conjugate of the equation number 3.1, that is the previous equation. So SI is the complex power, or we can say apparent power. So we are taking the conjugate of this two. So Pi minus JQI. So the equation will be Vi conjugate II. So I will be I we have that 1 to n. So substituting II is equal to this equation in equation 3.2. So we have this equation already of II, so we are substituting this value in this above equation. So SI conjugate is equal to Pi minus JQI is equal to Vi conjugate into, we are placing this value II, that is sigma k is equal to 1 n Yik into Vk, where I is equal to 1 to n. So by equating the real and imaginary parts, then we have the real power, that is Pi is equal to, this Re indicates the real power. So Vi conjugate sigma k is equal to 1 raised to n Yik into Vk. So this is the real part, and the imaginary part, or we can say reactive power, is Qi is equal to minus I m Vi, then sigma k is equal to 1 Yik Vk, where Im is the imaginary part. So we are just writing the same term for the real and reactive power. We are just indicate that Re, because this first term is positive and this second term is negative, that's why only just Im we placed Im with say the equation is minus. Now in polar form we can write as Vi is equal to Vi at angle delta 1, Yik is equal to Yik at angle theta ik, and Vk is equal to Vk at angle theta k. So these are the angle of respective voltages from the I bus means bus number 1 to the nth number of say bus, and the k is the means is the link from means nth number of links. So from that we can write this three equations, and the angles, that is for the Vi or say voltage angle is delta, and the admittance angle is theta, and the voltage at say respective links is theta k. So from the equation 3.4 and 3.5, the real and reactive power now we can be expressed as the real power is Vi, then it is sigma k is equal to 1 raised to n Yik Vk. This is the same equation. The change is that cos theta ik plus theta k minus theta I. So this is the real part of the equation or static load flow equation, and the reactive part of the equation is just we are putting this minus Vi, sigma k is equal to 1 raised to n Yik Vk sin. The cos term is converted to the sine because we are writing the equation for the reactive power. So sin theta ik plus theta k minus theta I, where I is equal to 1 to n. So equation 3.6 and 3.7 are said to be the load flow, static load flow equations. So from that we will calculate the examples related to this equation. So this is the static load flow equation. This is the most MP theory, and this theory is repeatedly asked in your GTU exam. So try to solve it by your way, or do practice of this question and answer. Like now the topic number 3 in this lecture is bus classification. So in power system we have the nth number of buses, but these buses are classified according to their say transformation of the power, and from the sending end to receiving end we are classified buses in buses with different names. So let us discuss the bus classification first. So a bus is a node, means it is a part at which one or more transmission lines, load and generators are connected. So in this diagram you can see that we have this generating station. After this generating station we have the bus number 1, and voltage of this bus number 1 is V1. After bus number 1 we have the transmission line. The transmission line is indicated with say R plus jx. So we are considering only the reactance because resistance of the line is very negligible, so we are considering the reactance only, so it is indicated as jx. And the power of this transmission line is say P plus jq. P is the active power and q is the reactive power of the line. Then after we have the bus number 2, and the voltage of bus number 2 is V2, and we have two lines that are connected with the load. So from this we can see that the one or say many transmission lines, loads and generators are connected with is called the bus. Now bus number 1 is a generator bus because it is near to the generator. Bus number 2 is a load bus because the load is connected with, and bus number 1 and bus number 2 are connected through a transmission line of the reactance say jx. So this is the name of the bus number 1 2 is generator bus and bus number 2 is the load bus. Now it is not necessary. So from this we can define that it is not necessary that all of them to be connected to every bus, because we have different number of say links which are connected in the interconnected power system. So it is not necessary that all the links are connected with each of the buses. So the bus is indicated by say vertical line at which the number of components are connected. Say load is connected, then generator is connected. So this is the bus, and now we know that the each bus in a power system is associated with the four quantities. The first quantity that we already know, that real power, that is pi, reactive power. This real power is also called as true power, or the power consumed by the circuit or network. Then the reactive power, this is qi, this just because of the components or elements which are present in the transmission system. And voltage, magnitude vi, and the phase angle delta. So these are the parameters that we know the each bus in the power system is associated with. Now in load flow problem, generally we have 2 out of 4 quantities which I described in the previous slide, that 4 quantities we discussed. So out of that 4, say 2 out of that 4 quantities are specified and other 2 parameters are to be determined. So this is the load flow studies. So from that 4, they must have given the 2 quantities, and from that 2 quantities we need to determine the rest of the 2 quantities, and that we need to determine through the solution of the load flow equation. So this is nothing but the load flow studies. Now depending upon the quantities specified for the buses, say they are classified into the 3 types, namely say load bus, generator bus, and the slack bus, or we can say reference bus. Slack bus is also known as the reference bus. So buses are classified basically 3 names. Say load bus, so it is also called the PQ bus, and generator bus because the generating voltage we are transferring, that's why it is called PV bus, and the slack bus or the reference bus. So the buses are classified in 3 different names. Now starting with the load bus, so if we describe the load bus over here, so it is also called the PQ bus. So the buses at with the PI means the active power and the reactive power are specified or known as load bus, and the magnitude and phase angle means the rest of the 2 quantities, that is Vi and delta I, are that needs to be obtained using load flow solution. So this is also called the PQ bus, and this type of bus are the most common, comprising almost 80% of the buses in a given power system. So this is the most important part of the power system and for the load flow studies. Now second is the generator bus, or say voltage control bus, or we can say PV bus. So from this the name of this bus is PV bus. So voltage, magnitude Vi, and the active power Pi are specified is known as the generator bus, and the rest of the 2 terms means except these 2 terms are the Qi and the delta I, needs to be solved with the help of the load flow solution. So this is also called the PV bus, and this bus has always generator connected to it, so that's why it is also called the PV bus. We are transferring voltage, means sending from the sending end of the transmission system with the help of generator. That's why it is called the PV bus. And this type of buses comprises about 10% of all the buses in power system. So rest of the buses are connected with links and loads, and the 10% of the buses which are connected with the generator. Now the third is the slack bus, or we can say swing bus or reference bus. So from this this bus having the voltage magnitude Vi and the voltage phase angle delta E are the specified, and real and reactive powers are needs to be obtained through the power flow load flow study or load flow solution. So normally there is only one bus of this type in a given system. The largest generator is connected with this bus, so the generator bus is selected as the reference bus. Generally the reference bus is connected indicated only when it is connected with the generator. So in this slack bus, the magnitude and the phase angle of the voltage is normally say considered 1 at angle 0 pu. So we have all the data in the power system is in per unit, so that's why the from the slack bus it is indicated at 1 at angle 0. Now this discussion can be summarized in the tabular form that is given below. So we are just discussing this too. So from this you can easily remember that which quantities are specified and which quantities needs to be specified or needs to be obtained with the help of load flow studies while these buses are present in the transmission system. So bus classification, the first bus is reference bus or slack bus. So as you already discussed that the Vi and delta E are quantity are the specified quantity on this bus, and thus the quantities to be obtained, that is Pi means active power and the reactive power. And the second case, that is generator bus or say voltage control bus, or we can say PV bus. So this is the bus at which the generator is connected. So Pi is the say active power and Vi is the voltage, means so these two are the quantities that is specified on this bus, and the quantities that we need to obtain when this bus is indicated, that is active means reactive power and the phase angle delta I. And for the load bus or PQ bus, so for PQ bus the PQ is present, means for active power and reactive powers are present, and we need to check the voltage and the phase angle. We need to obtain voltage and the phase angle from this given data. So this is the summary of the bus classification. We can remember, or we can say memorize these things with the help of this tabular form. Now this is the important question. This theory can be asked in the GTU like this: why one of the bus is taken as the slack bus in the load flow study? Also classify the buses. So this is the things that describes the one of the bus is the slack bus in the load flow study. So first is the load flow study. In the load flow study, real and reactive power, the complex power cannot be fixed, because this powers can be means fluctuating or changing due to the change in the element characteristics which are present in the transmission line or transmission system or generate the whole power system. So the complex power flow into the network is not known in advance, because S is equal to P plus JQ, and S is the resultant of active power and the reactive powers. That's why this power, the above powers are continuously varying or changing. That's why we cannot predict, or in advance we cannot say that the complex the value of the complex power. Therefore the system power loss is not known, because as we do not know the complex power, or we can say apparent power, so we cannot describe the power losses because it is not known at the time when we start the load flow studies. And till the load flow studies is completed, until the load flow study completed, means till the load flow study is completed, we can define that these are the losses, and this much amount of losses will take place in the power system. Now so that one of the bus is taken as the slack bus in load flow study. While we perform the load flow study, so the generally the bus connected to the largest generating station, as I already discussed in the previous slide, that the bus which is connected with the largest generating station is selected as the slack bus, and the slack bus is usually numbered as bus number 1. So this is the reason, that's why we take the slack bus while we do the computation of the load flow study for the power system. So after this presentation, we have the worksheet question. First question is, what do you mean by load flow studies? Also explain the necessity of the load flow study. And the second question is, why one of the bus is taken as the slack bus in the load flow study. The assignment questions are give bus classification in detail, and the second question is, define static load flow equations with suitable derivation of real and reactive power of the transmission system. The related instructions for the worksheet question and assignment question is just written below this worksheet question and assignment question. Please read it carefully. You can take the snap of this slide, and if you have any query and any doubt related to this topic, feel free to ask me in our doubt solving session. Also, you are feel free to call me anytime related to the doubt of this topic or this chapter, or any of the doubt of the subjects electrical engineering. So thank you very much, student. Thank you all. Jai Swaminarayan.